Join today to take your SAT prep to the next level. Members get access to over 1,000 solution videos answering the questions in College Board's question bank and concept-based practice questions with videos to solidify your SAT skills. Thanks for watching. Grateful. Starting on question number 1 now, here we have a nice straightforward question where we're seeing that x is equal to 7. So if x is 7, we can plug that in, and we'll get 7 plus 20, which is 27, and the answer is C. Going over to number 2 now, here we're being asked about the means of the two data sets, x and y. And data set x has these numbers, 5, 9, 9, and 13. Data set y has the same 4 numbers, and a number that's bigger than any of the other numbers. So without necessarily having to do the math, we know that data set y is going to have a bigger average. So the answer that says that is B. It says the mean of data set x is less than the mean of data set y. Going over to question 3 now, here we have two similar triangles, and the thing to notice is that the names line up in terms of how they lay out on the figure. So if you have PQR in this order, you'll have STU in that same order. And that makes a lot of sense because the corresponding parts have to line up both in the shape and in the naming. So we're seeing that angle Q has a measure of 18 degrees, and the angle that corresponds to that is T. So we can automatically say T also has a measure of 18 degrees. Now we're being asked for angle S, and we can just go ahead and utilize the fact that the three angles of a triangle add to 180. So 90 plus 18 plus the one we don't know, let's call it X, they add up to 180. So combining the 90 and the 18, that'll give us 108 plus X is 180. Take away 108 from both sides, and you get 72, which is answer choice B. Going over to question 4 now, here we're hearing about the amount of propellant in a rocket. We're seeing that at 0 seconds, which is just the initial part of the problem, there was this much propellant, and after 21 seconds, there was this much propellant. And sort of the inherent X is the number of seconds, and the inherent Y is the amount of propellant. Then we're being asked, on average, how much propellant was being burned per second. Now that statement right there, what's the amount of propellant being burned each second? To me, that sounds like slope. But if I'm a student who's not quite sure, there's a way to test that out. And we call this translating slope. So in translating slope, you say to yourself, well, slope, that's your change in y over change in x. And then you substitute in what the question's talking about. So according to how we set this up, the y is the amount of propellant. So it's the change in the amount of propellant. And the x is the number of seconds over the change in seconds. So if our statement is the slope, then it'll sound like this: the change in propellant for every change in the number of seconds. And does it sound like that? Let's look at it again. How much propellant is the rocket burning each second? So what we're doing is we're using the translating slope method to confirm that yes, all this question's asking us for is the slope. So let's just go ahead and use our slope formula, y2 minus y1 over x2 minus x1. And if you want to go a step further, you can label one set of points x1, y1, the other x2, y2. That makes it really easy to just throw them right into the formula. 362,105 minus 467,000 over x2 minus x1, 21 minus 0. So you get an easy 21 on the bottom, and you get negative 104,985 on top. When you divide it out, you get negative 4,995, and that matches answer choice A. Now, the negative is not there in the answer because we know that it's the amount that's being burned each second. In other words, there's an implied negative in the wording, so we don't actually have to see it in the answers. But once again, the answer is A. Going over to question number 5 now, this looks like a system of equations, but we may not really call it a system because the first equation only has one variable. If x is being multiplied by 4, then the opposite is to divide by 4, and we'll have x equals 5. Now we can plug that into the other equation. We can say negative 3 times that 5 plus y is negative 7. And the 5 is going right here. So we'll have negative 15 plus y is negative 7. And so what's happening to y right now? It's being added with negative 15. So 15 is being subtracted from it. So what's the opposite of that? Go ahead and add the 15. So that's right here. And we'll have y equals 8. And so x is 5, y is 8. What is x plus y? It's 5 plus 8, and that's our answer. It's 13. Now going over to question number 6. Here, this is a question we refer to as linear with heavy unit conversions. You can understand this by treating it like a chemistry-style unit conversion. So to start this, we'll leave a lot of space, and we'll kind of see why in a second. But right now, we're leaving all this space, and we're also realizing that any number is really a fraction. So any number is really itself over 1. And some of these items in this word problem have units attached to them. In other words, we know that 85 is the number of hours. And we know that X is the number of courses. So we can say we have X courses, and that's for the on-site on that part. And Y is the number of courses that are online. So we'll put the word courses right here. And the question is, what unit would we need in this empty space right here and also right here to make this work? And I'll actually kind of open the parentheses so they include the numbers themselves. But in other words, 10 has to be the number of what's so that when we combine it with courses, we end up with hours. And there's only one way to answer that question. 10 has to be the number of hours for every course. And same thing for 15. 15 has to be the number of hours per course. And the reason why that has to be the case is because if we have courses right here, and we're going to have courses right here, so we'll have that same combination here and here, because from a unit conversion standpoint, when you have one on the top and one on the bottom, they cancel away. And this works because now we have 10 hours, 15 hours, and that's going to give us 85 hours. So we figured out how to set this up, how to understand the units so that this whole thing mathematically makes sense. But we're going to go ahead and just leave these not highlighted because the question is asking us how many more hours does the online course take than the on-site course? In other words, we need to understand what the 10 and the 15 mean. And from all this work we did, we see that 10 is the number of hours per course for the on-site. 15 is the hours for each course for online. So how many more hours for each course when you're talking about online versus on-site? Well, that's simply 15 minus 10, which gives you 5. And that is the difference in the number of hours per course. And so our answer here is 5. Let's go over to number 7 now. Here, we're seeing that we have square x and square y. Square x has a side length of 12. The perimeter of square y is double the perimeter of square x. And the little factoid you need to know here is that for similar shapes, the ratio of the perimeters to one another is equal to the ratio of the sides to one another. That may or may not be obvious to some people, but it's important nevertheless. Now, how do we know these are similar? Because they're both squares. Similar means that shapes have all the same angles and proportional sides. And so because these are squares, any one square is similar to any other square. So if we have x to y, if we know that the perimeter of y is double the perimeter of x, then the ratio is kind of 2 to 1 in this direction, or 1 to 2 from the top down. And square x has a side length of 12. And so let's call this a. So here we have the ratio of the perimeters. And here we have the two sides, the ratio of the two sides. And now we can just cross multiply. 2 times 12 equals 1 times a. Multiply on the left, 24 equals a. And that's our answer, D. Going on to question 8 now. Here we have a function discussing the number of gallons of gasoline after driving a certain number of miles. Then we're being asked around how many gallons of gasoline are used to drive each mile. And that should sound like a slope question, because slope is the amount of change in this for every change in that. For here, it sounds like it's the gallons of gas for the number of miles. But still, we can't be sure unless we use this method, which we call translating slope. So translating slope helps you to deal with the fact that the SAT will ask a lot of these sort of in-depth questions, really asking you to demonstrate that you understand what slope is in some kind of real-world scenario. And so all you have to do is start by writing slope is change in y over change in x, and then you fill in the units for the y and the x in this particular question, and that will confirm for you whether or not you're talking about the slope. So here, this is in the y equals mx plus b format. So the y for our situation is the g of x, or the g of m. And g, we're being told, is the number of gallons. So if we say slope is change in y over change in x, the y is the gallons. So that's the change in gallons. And the x in this question is the m, which we're told is the number of miles. So change in y, change in x is change in gallons over change in miles. So we have our slope statement is the change in gallons for every change in miles. And then we match it up with this. How many gallons of gas are used to drive each mile? And they do match each other. And we've confirmed that what we're looking for is the slope. So in slope intercept, y equals mx plus b, this is the slope, this is the y-intercept, and so our slope is negative 0.05. So the gallons of gas is going down by 0.05, and any numbers itself over 1, so every time they drive 1 mile, which is the each mile right there. So the fact that there's no negative sign is okay, because we're talking about using the gas. In other words, the amount of gas is going down, so the negative sign is implied in the wording. So the answer for 8 is A. Join today to take your SAT prep to the next level. Members get access to over 1,000 solution videos answering the questions in College Board's question bank, and concept-based practice questions with videos to solidify your SAT skills. Thanks for watching. Grateful. Going over to question 9, here we're being presented with an absolute value equation. And for absolute value equations, you want to have the instinct of, in one situation, just taking away the absolute value symbols, and in the other, setting the same thing equal to a negative. So if we have absolute value 2x minus 3 equals 10, you set it equal to 2x minus 3 equals 10, 2x minus 3 equals negative 10. So now, by the way, why is that? That's because if we had the absolute value of a number, on the positive side, that would equal the number. But if we had the absolute value of negative 8, that would also equal 8. So in other words, if we have absolute value of an unknown number, but we know that that number comes out to 8, then x could be 8, or it could be negative 8. By the way, what's the one situation where an absolute value equation would yield only one answer? That would be if you had a 0 in there. A little bit of SAT trivia there. Coming back over here, we want to set our absolute value equation just equal to the positive and the negative. So on the left-hand side, we're just taking away the absolute value symbols. And on the right-hand side, you're setting it equal to negative 112. So 4x minus 4 is 112. 4x minus 4 is negative 112. And now from here, we're talking about corralling. Corralling as a vocabulary word is like the idea that you're moving things around all into one area. So just imagine you have a bunch of marbles on a table that are kind of rolling around uncontrollably. And with your arms, you kind of guide them all into one corner of the table where you want them. That's the idea of corralling. And so often the SAT will not ask you for X, but for something like this, for X minus 1 or 4X plus 5 or something very random like that. And if you can help it, you should go directly from what you have to what you need. So how can we go directly from 4x minus 4 to x minus 1? Well, coincidentally, there's a factor of 4. If you're simply dividing both sides by 4, then you're getting x minus 1 equals 28, and x minus 1 here equals negative 28 by dividing this side by 4. So we have x minus 1 is 28, x minus 1 is negative 28, and we're being asked, what's the positive value of x minus 1? Well, it's 28, and that's our answer. Going on to question 10, here we have an equation with a lot of variables, and we're being asked to get x by itself. To express x in terms of the other variables just basically means we want to end up with x equals something. But this equation we have is not just any equation, it's a proportion. A proportion is when you have two fractions set equal to one another, and the general rule is that you should cross multiply. AD equals BC. So in our situation, we want to say 1 times y equals 7b times 11x. So let's write that out. 1 times y, which is just y, equals 7b times 11x. We can simplify a little. This is 77bx, and we're trying to get x by itself. So right now we can tell ourselves, well, x is being multiplied by 77b. And the opposite is to divide by 77b. So that'll all cancel out. B over b cancels. 77 over 77 cancels. And right now we have x all by itself equal to y over 77b. And that is answer choice C for this question. Going to question 11 now. Here we have x and f of x. F of x is just a fancy way to say y. So we have an xy table. We're being told this is linear, and we're being asked for m. Now this expression here, that's a fancy looking y equals mx plus b statement. So this is another way to say this. And if they're asking us for m, that's just the slope. So let's use the slope formula. Y2 minus y1 over x2 minus x1. And so that's 137 minus 82 over 15 minus 10. And 137 minus 82 is 55. 15 minus 10 is 5. So that simplifies to 11. So our slope is 11, and that's the answer to this question. Going over to question 12 now. Many people doing this question incorrectly would start foiling it. If maybe you're in a rush, you might not see that there's a minus sign there. But that minus sign, you should treat it like a -1. So let's write a little 1 right here. And if you have a number outside of a parentheses, you're going to want to distribute it. So right now we'll have 5x cubed minus 3 plus 4x cubed minus 8. So -1 times each of those numbers, reverse the signs. Now we can just combine like terms. This will combine with this. 5x cubed and 4x cubed is 9x cubed. And -3 combined with 8 is simply -11. They said the answer is bx cubed minus 11. What's b? So you can see that what's lining up with b here is the number 9, and that's our answer. Going to question 13 now. This is a question that might look really tough to a lot of people, but it's a great time for a lesson on how to generally approach questions. A lot of people looking at this question might not really know where to start. And if your fundamental starting question in your mind is, how do I solve this? That's a little too daunting on some of the tougher questions. Instead, you should be asking yourself, what can I do with the information I'm given? So one thing you can do here is graph it. And that may or may not get to an answer, but a nice, easy thing you can do is simply plug in what they gave you. If they're telling you when x is x, then y is 53, let's go ahead and just plug that into the situation. So if y is 53 here, we get 53 greater than 14. Well, yeah, that makes sense. 53 is greater than 14. But what if we plug it in here? So 4x plus 53 is less than 18. Take away 53 from both sides, and you get 4x is less than negative 35. Divide both sides by 4 now, and x is less than negative 8.75. And so what are they asking us for? Which of the following could be a value of x? Well, if you think of this on a number line, you have 0 right here, you have negative 8 right here, negative 9 right here. So negative 8.75 is around here. And we're seeing that x is going from there in the smaller direction. So which of these answers is in that area, in that domain? And that, of course, is the negative 9, which is right there. So the answer here is A. Now going to question 14. Here we have a situation where there are 300,000 bacterial cells, and that amount is doubling every 3 hours. So right now, it's important for you to be able to identify that that's an exponential equation. What is an exponential equation, an exponential function? That is a situation where as x goes up by 1, we're multiplying y by the same amount. On the other hand, if every time x goes up by 1, you're adding the same amount, that's a linear. So some people at the earlier stage would say, well, if something's increasing by a constant amount, that's linear. And it's actually more complicated than that. If it's increasing through adding, it's linear. But if it's increasing through multiplying, it's an exponential. And that's what's happening here. Here it's doubling, which means we're multiplying by 2. And so let's get to know exponential equations a little bit better. The basic exponential equation looks like this. Y equals a times b to the x. A is the starting amount. B is the way it changes in this situation. It's doubling. And x is the number of times that happens. And you're going to see two main variations to that on the SAT. You can have something doubling every number of years, let's say, if we're talking about years or hours or second, or every time x is going up by 3, here we would have the change happening. And so x over 3 means it's happening every 3 whatevers. On the other hand, if you see something like a 3x there, that means it's happening 3 times every whatever. So of course, we're just using the number 3 here as an example of any number that can be in that area. So coming back to this question, we have something in the format of a times b to the x over some number. And that's because it's starting at 300,000. It's doubling every 3 hours. So that's matching exactly with this diagram here. And what is the number of hours? Well, that's 15. So that'll simplify to 300,000 times 2 to the 15 over 3, which is 5. Now you can throw that right into your calculator, and you should get 9,600,000, which is D. Going to question 15 here. Here we're seeing a graph, and we're being told that the y-axis is the number of catalogs. So it's the number of catalogs. But it's not just the number of catalogs, it's in thousands. And that's an important little SAT piece of terminology dating back to the print SAT starting in 2016. It's the number of thousands of catalogs. And little differences like that can really throw you off. So we want to emphasize them. So in other words, here, this 9, that means there were 9,000 catalogs. And the x-axis is the number of years since the end of 1992. So let's say that years since the end of 1992. So in other words, this 1 right here, that would be, I guess, the end of 1993, because it's 1 year after the end of 1992. So we're being asked, what is the y-intercept here? So the y-intercept, that's where you're hitting the y-axis. That's the 9. And so we're seeing that right at the end of 1992, because it's x equals 0. So it's 0 years after the end of 1992. We're seeing that there were 9,000 catalogs. So which answer says there were 9,000 catalogs at the end of 1992? Answer choice D. Going to question 16 now. Here we have an exponent radical expression. And so to make better sense of that, let's review our exponent rules. If you have a to the b times a to the c, that's a to the b plus c. So when you're multiplying, you're adding. If we have a to the b over a to the c, that's the opposite. If we're dividing, we're subtracting. So we have these two rules as opposites of one another. Multiplying means adding, dividing means subtracting. And going to the next one, if we have a to the b all to the c, so an exponent of an exponent, a power of a power, then we multiply a to the bc. And the opposite of that rule is instead of taking it to a power, you're taking it to a radical, then instead of multiplying, you'd be dividing. So these two rules are opposites of one another. The way to really remember this bottom rule is you have the unit of a to the b that's being multiplied by c, or that same unit of a to the b with the c dividing it underneath. So another thing we want to know here is that to make better sense of these things, we should separate them out. So there's nothing wrong with that. 7th root of x to the 9th and the 7th root of y to the 9th. So now utilizing our 4th rule of kind of memorizing which one goes on the top and which one goes on the bottom of the fractional expression, that would have us saying that this here is x to the 9 over 7, and this one is y to the 9 over 7. So we've got x to the 9 over 7, y to the 9 over 7, and we can just go ahead and say that that's like taking xy all to the 9 over 7. Because if we had it in this situation, we could easily separate it back out, essentially distributing that exponent to each part. So the answer here is B. Join today to take your SAT prep to the next level. Members get access to over 1,000 solution videos answering the questions in College Board's question bank, and concept-based practice questions with videos to solidify your SAT skills. Thanks for watching. Grateful. Now we're going to question 17. Here we have the population of city A increasing by 7%. And the question is asking us, essentially, what do we need to multiply the 2015 population by to show that it increased by 7%? And what we're really talking about is the idea that to increase or decrease something by 1%, you have to always start at 100 and then increase or decrease from there. So if we started at 100 and increased by 25%, it would take us up to 125%, and in decimal form, that's 1.25. If, on the other hand, we decreased by 25%, that would take us to 75%, which in decimal form is 0.75. This idea comes up a ton on the SAT. So for us here, if we're starting at 100%, and then we're going up by 7% from there, that takes it to 107%. And to get from percent to decimal form, you take that decimal, and you move it 2 spaces over, so it becomes 1.07, and that's what we would have to multiply by to increase by 7%. So the answer here is C. On question 18 now, we're being asked which of these systems of linear equations has no solution. And the background here is the idea of the number of solutions for two lines. If two lines have one solution, that means they're hitting once. And that would happen if the slopes are different. If they're tilted in different directions, they'll hit once. If there's no solutions, that means that they're parallel. And to be parallel, the slopes have to be the same, but the y-intercepts have to be different. And if there are infinite solutions, it means that they're really the same line, or they can be thought of as two different lines that overlap. And that would happen if the slopes and the y-intercepts are the same. So coming back to our question, which of these has no solution? We're looking for a situation where the two lines are parallel, they have no solution, they never hit each other. And like we said a moment ago, that would happen if you have the same slopes, but you have to have different y-intercepts. And most of these are in the format of y equals mx plus b. So looking at answer choice C, we have the same slope, but we do have different y-intercepts, and that's what we need. So the answer here is going to be C. Now going to question 19. Here we have a sequence where the first term is 9. After that, each term is 4 times the preceding term. In a way, this sounds like an exponential equation, and it is, but there's one twist. Just to review the exponential equation, there's a starting amount, which is your A. It's changing by some amount, which is the B. And X is the number of times that all happens. So here, we can kind of model this after the exponential equation. We can say the first term is 9, and we're multiplying by 4 every time. And n is kind of the number of times that happens in a sense. But this actually won't work, and let's show you why. So let's create a little XY chart. Actually, instead of calling this Y, let's call it W, like the question does. So we have N, which is our X, and W, which is our Y. And let's just go to the first couple of terms here. When N is 1, we would have W equals 9 times 4 to the 1. And that's 9 times 4, and that's 36. So we needed the first term to be 9, and it ended up being 36. If we go ahead and do the second one anyway, that would be 9 times 4 to the 2. 4 to the second power is 16, and that's 144. So our first term is 36, and our second term is 144. So this is not working in the sense that we need the first term of the sequence to be equal to 9. So what can we do instead of that? What we can do is we can replace this exponent of n with a slight variation. We can shift it up or down by 1. And what we need to actually do is shift it down by 1, make it n minus 1. So instead of having 9 times 4 to the n, we're going to have 9 times 4 to the n minus 1. That's going to have the effect of shifting each term down 1 on the xy table. So let's show that. Let's say we have n and w, which is the x and the y of this question. When n equals 1 right now, look what we'll have now. We'll have 9 times 4 to the 1 minus 1. That's 9 times 4 to the 0. Anything to the 0 power equals 1, so it's just 9. And the second term would be 9 times 4 to the 2 minus 1. And 2 minus 1, of course, is 1. So that's 9 times 4 to the first power, and that's 36. So by taking that exponent of n and making it n minus 1, we've made it happen the way it's supposed to happen, which is that the first term was supposed to be 9 right here. And so which answer matches this equation? 9 times 4 to the n minus 1. Answer choice D. Now going over to question 20. Here we have something of a complicated algebraic statement. And what makes it really complicated is the idea that we're talking about a minimum value. In other words, an inequality statement. So to make it simpler, let's just pretend for a moment that we're not seeing the inequality statement. We're just seeing x is 12 less than 6 times n. So that's nice and easy. X is 12 less than. If I want to lower something by 12, I can just add negative 12 to it. So x is 12 less than 6 times n. So that would be if our statement was not an inequality statement, if it was just a regular equation. So now let's bring back the inequality. This is saying instead of having x being equal to, we're saying the minimum value of x is this. So if this thing is the minimum, that means that we could have this thing or we could have something greater than that thing, because that's what it means to have a minimum. If I say the minimum amount of money I'm going to make tomorrow is a certain amount, it means I could potentially make more. So instead of saying x is equal to all this stuff, we're going to say x is greater than or equal to all this stuff. And there we have it. That is our answer there. And the one that matches it is going to be answer choice B. X is negative 12 plus 6n. Going over to question 21, here we're hearing about two triangles, RST and UVW. And an important detail is that they're right triangles. So let's draw one right triangle and let's label the side lengths. TR is 52. That's the longest one. And in a right triangle, the hypotenuse is always the longest side. That means that this right angle here has to be S, and RS is 20, and ST is 48, and this is obviously not to scale. But for similar shapes, the order of the naming matters. So if we have RST in that specific order, it goes like this, RST in that order. And when we draw the similar matching triangle, similar means they have the same angles, but the sides are actually proportional. So to draw identical triangles is maybe misleading, but we're just trying to get an image of where everything goes. But if we have RST in that order, we're going to go ahead and do UVW in that order. So we're paying attention to the ordering of the naming, and that kind of takes care of setting up each corresponding piece. So UVW with the right angle right here. And let's just confirm that we did it right. S corresponds to V, check. And T corresponds to W, check. So everything matches up exactly perfectly. And so we're hearing about the tan of W. So this is our theta. And what does it mean to be similar? It means they have the same angles, not the same sides. The sides are proportional, but they have the same angles. So if we're being asked about the tan of W, we may as well be asked about the tan of T, because they're the same angles by definition. So now we're turning to some trigonometry steps. If you're doing SOHCAHTOA, right triangle trigonometry, the first thing you're going to want to do is go straight out of your angle and call that one there the opposite. The hypotenuse of a right triangle is a little easier to find. It's the slanted side of the right triangle across from the right angle. And the one left over, that's the adjacent. So we have opposite, hypotenuse, and last but not least, adjacent. And in SOHCAHTOA, that phrase tells us that the sine is the opposite over the hypotenuse, the cosine is the adjacent over hypotenuse, and the tangent, tan, is opposite over adjacent. And so tan of W is the same as tan of T, and that's the opposite over the adjacent. So 20 over 48 for the left triangle. And now we can just simplify that, 10 over 24, 5 over 12. And so tan of W, which is the same as tan of T, is 5/12, and that's answer choice B. Going to question 22 now, we have a line right here. We know it's a line because x and y are to the first power. If x were to the second power, it would be a quadratic, a parabola, and it's being translated down 4 units. Now, if you're given the equation of a line, you really want to see it in y equals mx plus b form so you can make sense of it. So let's do that. We have 9x minus 10y equals 19. We want y equals mx plus b. So let's take away 9x from both sides, and we'll have negative 10y is negative 9x plus 19. Now, I wrote the x before the 19, and that's because we're thinking in our minds that we need to have this looking like y equals mx plus b. So negative 9x plus 19 is so much better than 19 minus 9x. Now we can divide by negative 10 on both sides, and we'll have y equals positive 9 over 10x minus 19 over 10. That's because when we multiply or divide by a negative, the same sign, so negative 9 over negative 10, gives you positive, and opposite signs, 19 over negative 10, gives you a negative. So now we have the equation of this line. It starts at almost negative 2, and then from there it'll go up 9 and over 10 on a graph. And we're seeing that this is all being translated down 4 units. So let's talk a little bit about translations. Let's say we have a nice parabola, y equals x squared, as our basic function. If we add to the outside of that, that's a vertical shift, and vertical shifts are normal. So positive is up and negative is down. So if you add 5 on the outside, that would be pushing the parabola up 5. If, on the other hand, you add to the inside of it, by the inside, I mean replacing x with x plus 5. That would be a horizontal shift, and those are backwards. Normally, positive is to the right and negative is to the left. So here, positive would be to the left. So this would be left 5. In f of x language, this would be f of x, this would be f of x plus 5, and this would be f of x plus 5. So for us, this is being translated down 4 units. A vertical shift means you're adding to the outside and it's normal. So to translate down 4, we simply want to subtract 4 from it on the outside. And so now we can use our calculator or not to get this. So we'll have 9 over 10x minus 19 over 10. And this, with the denominator of 10, is negative 40 over 10. So right now we have y equals 9 over 10x minus 59 over 10. And now we can look at the fact that we're being asked for the x-coordinate of the x-intercept. And one of the fundamental rules is that the x-intercept is the moment when y is 0, and the y-intercept is the moment when x is 0. So the x-intercept, for us, that means y is 0. So let's go ahead and replace y with 0. Next, we can add 59 over 10 to both sides. So 59 over 10 equals 9 over 10x. We can multiply both sides by 10, and we'll have 59 equals 9x. And next, we can divide by 9. And x equals 59 over 9 for question 22. Join today to take your SAT prep to the next level. Members get access to over 1,000 solution videos answering the questions in College Board's question bank, and concept-based practice questions with videos to solidify your SAT skills. Thanks for watching. Grateful.